It's chemistry and you are watching Chem Science.
Welcome to our channel. In our earlier video, we have already discussed question paper 6.2 of the May-June 2023 series of IGCSE chemistry, and in this video we'll be solving question paper 6.1 of the same examination series. So let's start with the question paper. So here is question 1, and it says ethanol can be made by fermentation of sugars found in plants. A byproduct of fermentation is carbon dioxide gas, and here are the steps which is performed to produce ethanol. That is, cut some sugarcane and crush it, add hot water to the sugarcane and stir and to dissolve the sugar in the sugarcane. Remove the solids from the mixture to obtain sugar solution. Let the sugar solution cool and then add yeast. Place the mixture obtained in the apparatus shown in figure 1.1, and here is the apparatus shown down here. Step 6, last one, leave the apparatus until fermentation is complete. Now let's see the apparatus. How is the apparatus looking down? Here is the apparatus, and it's all about the conical flask with the sugar solution and the yeast. And then there is a tube going out which is dipped inside the lime water in a test tube. Now the question says it's name the item of the apparatus labeled A. Now the label of the apparatus is to the conical flask. So let's write conical flask, which is apparatus A. Now the next sub question says explain why hot water rather than cold water is used in step 2. Now let's see what is step 2. Step 2 says that add hot water to the sugarcane and stir to dissolve the sugar in the sugarcane. Now if we are adding hot water to the sugarcane to dissolve sugar, then obviously hot water is going to make the dissolving faster. So we can write to dissolve the sugar, to dissolve the sugar faster, because that's the reason that we can make our process faster. Okay, name the method used to remove the solids from the mixture in step 3 and draw a diagram to show how this is done. Now in step 3 what they have done is they said remove the solids from the mixture to obtain the sugar solution. So if we want to remove the solids out of the sugar solution, obviously the name of the process is a filtration, because we want to remove the solids out of the solution. Now if we want to draw a diagram, obviously we have to draw a conical flask, where in the conical flask we will be adding conical funnel on the top of it. Conical funnel on the top of it. Now obviously if I am drawing with a cursor, my diagram is not very good, but with pencil, scale, eraser, this diagram can be better. Now in the conical flask we need to add filter paper. So here we need to label it filter paper, filter paper. This one is filter funnel, filter funnel, filter funnel, and then conical flask, conical flask. This is how we are going to label the whole apparatus. We might draw the solution here and we might not, that doesn't make any difference. At least our diagram should contain filter funnel, filter paper, and the conical flask showing the filtration process. So let's go ahead with the next question here. The D sub question says state why the sugar solution is allowed to cool before the yeast is added in step 4. Now if we are adding yeast to the solution needs to be cool, because the yeast gets denatured at a higher temperature. So we can write at higher temperature, at higher temperature, at higher temperature, the yeast doesn't work, or the yeast gets denatured. The yeast gets denatured. Denatured is a specific word, rather than just writing doesn't work. So we need to cool the solution. Cool the solution, as yeast doesn't work, so cool the solution before adding the yeast. Describe how the appearance of the lime water changes as the fermentation takes place. Now it's already written in the question. If you go back and read the question, it says during the fermentation carbon dioxide gas is produced. So when the carbon dioxide gas is produced and it is passed to the lime water turns milky. We can write lime water turns milky, or you can even write lime water turns cloudy. That is also acceptable. Lime water turns milky. Next is describe how the student could tell that the fermentation is complete. Now as we know that a gas is produced during the reaction, so obviously the gas can be seen in the form of bubbles. So we can say that the bubbles are stopped. Bubbles are stopped being produced. Bubbles are stopped being produced during the reaction or during the process. So that's how we'll come to know that the reaction is over or reaction is complete. If we go ahead with the next sub question, it says name the process used to separate ethanol from the mixture obtained by fermentation. Now here is a mixture obtained of ethanol, and obviously if the solution is of a glucose, obviously the full glucose doesn't turn in ethanol. So if we want to separate ethanol from the mixture, obviously now the mixture carries two liquids, right? Because it's a sugar solution also and ethanol is also a liquid. So to separate two liquids, the best process is a fractional distillation. Fractional distillation is the process or the separating technique which is used to separate two liquids. So here if we are separating ethanol and mixture, it's a fractional distillation which we are using. So here is the end of question 1. Let's go ahead with question 2. Question 2 says a student investigates the reaction between aqueous ammonia and two different aqueous solutions of copper sulfate labeled A and B. Solutions A and B have different concentration. The student does two experiments. Now understand what are we doing? We are performing an experiment with two different solutions of different concentrations of copper sulfate, and this copper sulfate solutions A and B are separately reacted with aqueous ammonia. Now we should remember that an aqueous ammonia is reacted with copper sulfate. Now starting with the experiment 1, it says fill the burette with solution A. Run from solution A out of the burette so that the level of the solution A is on the burette scale and record the initial reading. Now what we are doing is just level the burette liquid, the solution A in burette such a way that it is up to some mark exactly. It can be 0, it can be some other mark, or the volume of the graduations which is shown on the burette. It can be anything, but it should touch exactly some level. That's what they're trying to say. Record the initial burette reading. Use the measuring cylinder to pour 25 centimeter cube of aqueous ammonia in a conical flask. Now understand what are we taking in the conical flask? Aqueous ammonia, and copper sulfate is taken in the burette. Now stand the conical flask on a white tile. Slowly add solution A from the burette to the conical flask while swirling the flask until the mixture starts to become cloudy. Record the final reading. Now experiment 2. Empty the conical flask, rinse it with distilled water, empty the burette, rinse it with distilled water, rinse the burette with solution B, and repeat the experiment, same experiment now with solution B instead of solution A in the burette. Okay, and here we have the burette readings of experiment 1 and experiment 2 with initial reading and final reading. So if we talk about the initial and final reading of experiment 1, it is 0.6 centimeter cube, and the final reading is, I think it is 18.3 So for experiment 2 it is 9.2 and it's exactly 21.0. So let's go ahead and fill up the table. So for experiment 1 the initial reading was 0.6 and 18.3, and for experiment 2 it was 9.2 and 21.0 exactly for experiment 2, the final burette reading. And so if we subtract these two, the volume of the aqueous solution will be 17.7 and 18.2. Sorry, it's 11.8. So here are the readings of experiment 1 and experiment 2. Explain why white tile is used during the titration. Now the white tile is generally used so that we can see the change in the color very easily. So here we can write to observe or to see. To observe or to see the color change easily. Color change easily. Color change, or it may turn cloudy, it may turn blue also. So that's the observation and that can be seen easily, so we use white tile. In experiment 2, the burette and the conical flask are both rinsed with water. The burette is then rinsed with solution B. Now that is done before starting the experiment 2 after the finish of experiment 1. State why both the burette and the conical flask are rinsed with water. Now the answer is as simple as that: to remove or to wash off the solution A fully, to wash off the solution A. That is the simple reason. Before using experiment 2, before using solution B, we should remove the solution A completely. Explain why the burette is then rinsed with solution B. Now obviously if after using the distilled water, if we are rinsing the burette with solution B, that is to remove the water, from the burette. That is the reason that we rinse it with solution B, to remove the water from the burette. And if the water stays in the burette, the only problem which creates is the concentration of the solution B might change. So it's very necessary to remove out the water. So we remove the water by rinsing the burette with the same solution which we are going to fill inside the burette. That is general process when the titration is done during any experiment. Next up question says, describe how the result of the experiment 2 would be different if the conical flask is rinsed with aqueous ammonia after rinsing with water. Now this question can be asked why, because if we are rinsing the burette with the solution B, then why can't we rinse the conical flask with the ammonia? Now the problem is that if we rinse the conical flask with ammonia, the amount of ammonia, the volume of the ammonia inside the conical flask might increase, because some of the ammonia is obviously going to stick to the wall of the conical flask. So if conical flask is having more ammonia, more of the solution B in the experiment 2 would be required. So they have asked, describe how the results. You need to describe what will be effect on the result of experiment 2, and we need to explain the answer. That is to give the reason. What do you mean by explain? To give the reason. Reason is required when it's asked to explain. So what would happen to the result? The solution B will be required in greater volume, or will be required more. That also we can write, will be required in greater volume, because the amount of ammonia, or the volume of ammonia increases. Volume of ammonia increases in conical flask. So volume of ammonia increases, solution B will be required in a greater volume. That is the main reason, and that is how the experimental results will be affected. Next, the sub question D with 1 says, deduce which solution of copper sulfate, A or B, is more concentrated. Explain your answer. Now let's first understand what was the process before actually answering the question. It was like ammonia was filled up in the conical flask, and we were adding solution A or B from the burette in the conical flask. So here was the ammonia. Now ammonia concentration is same in both the experiment experiment 1 and experiment 2. So what is changing is the concentration of A and B. So if any solution is more concentrated, that will be required in a smaller volume to turn the aqueous ammonia cloudy. So if the solution is required less, that will be more concentrated. Now what we have deduced was that solution A required was 17.7 centimeter cube in experiment 1, and experiment B we required 11.8 centimeter cube. So these were the two solutions required. Now which one was required in a lesser amount? B. So solution B was more concentrated. Solution B was more concentrated because it was required in smaller volume to turn aqueous ammonia cloudy. So that was the reason that we found out the solution B was more concentrated. Deduce how many times more concentrated this solution of copper 2 sulfate is than the other solution of the copper sulfate. Now if we look at both the readings again, 17.7 and 11.8, if the solution B is double the concentration of A, then exactly half the volume of A should be required. So if we divide 17.7 by 2, we get the answer 8.85. But no, it's not this less. It's little greater than 8.85 centimeter cube. So that shows that solution B was not double. We can rather say it's approximately 1.5 times greater. So let's read the question again. It says how many times more concentrated this solution of copper sulfate is than the other solution. So we can say that it is 1.5 times more concentrated. What is 1.5 times more concentrated? Solution B is 1.5 times more concentrated than solution A. Let's go ahead with the next sub question. It says describe how the reliability of the results obtained can be checked. The simple solution for checking the reliability is repeat the experiment. Repeat the experiments and compare the results as simple as that. If we check the reliability, compare and check if the results obtained are same or not. If it's same, the experiments are quite correct. Deduce the volume of solution A required in experiment 1 if it's carried out with 10 centimeter cube of aqueous ammonia. So before we answer the solution, let's look at the process again and find out how much of solution aqueous ammonia was taken. It's 25 centimeter cube, and now if we are taking 10 centimeter cube, here 10 centimeter cube. So simple solution is that if we are using 25 centimeter cube and we require 17.7, then 10 how much we will require. Simple as that. So for that we need to multiply 17.7 into 10 divided by 25, and we get the answer 7.1. So we need to write 7.1 centimeter cube of solution A will be required if it's carried out by 10 centimeter cube of aqueous ammonia. In experiments 1 and 2, the volume of aqueous ammonia is measured using the measuring cylinder. Given advantage and a disadvantage of using a volumetric pipette instead of measuring cylinder to measure the volume of aqueous ammonia if we are using measuring cylinder. And so it is replaced by volumetric pipette. What are the advantage and disadvantage? So the advantage of using volumetric pipette is that pipette is more accurate. Pipette is more accurate. It gives the volume more accurate. And what is the disadvantage? Disadvantage is that it is time consuming. It takes a lot of time to fill up the pipette and re-empty it. But using the measuring cylinder, it's quite quicker. Fill up the measuring cylinder easily and remove it to the conical or empty it to the conical flask. That's very easy. And here our question 2 also ends. Let's go ahead with the next question. Now let's start with question 3, where it's a qualitative analysis question, and the question says a student tests two solids, solid E and solid F. Now remember, both of it are solids. Now test on solid E. The table 3.1 shows the test and the student's observation here, and here we have the whole table. Now let's start with test 1. Test 1 says gently heat half of the solid E in a boiling tube. The observation is a solution forms, steam is given off, and condensation forms at the top of the tube. That is, the solution forms, that is the solid E dissolves, and it dissolves in water because it's written solution forms. It's not written the solid E melts. So obviously there is some water related with solid E. Now here it says steam is given off and condensation forms at the top of the tube. That shows that the solid E has water with it. That is, the solid E should be hydrated, solid hydrated compound where it has water molecules with it. So on heating, the solid E changes to solution and the water molecules are also evaporated, giving off steam, and this steam is condensed in the form of droplets at the top of the tube. So obviously this conclusion and this observation, we can conclude that solid E is an hydrated solid. Let's go ahead with the test 2 of solid E. It says dissolve the remaining solid E in water to form a solution E. This means that half of the solid we have already taken in the boiling tube and we had heated. The remaining half we are dissolving in water to form a solution. Now divide solution E into 3 portions. To the first portion of solution E, add aqueous sodium hydroxide dropwise and then in excess. On adding NaOH, that is sodium hydroxide, we get brown precipitates forms, which remains when excess is added. Which remains means the brown precipitates are insoluble in excess sodium hydroxide. Now remember this test, we are going to compare these observations with the table which is given on the last page of this question paper. So our first observation on sodium hydroxide with sodium hydroxide aqueous solution is brown precipitates which remains insoluble. Now test 3 says warm the product of test 2, that is the solution which we have obtained here after the precipitates. Test any gas produced. The gas turns a red litmus paper blue. That shows that if any gas produced turns red litmus paper, then obviously the gas produced is a basic gas, and that is ammonia gas. Ammonia is produced on heating any compound with NaOH, and if it turns red litmus paper blue, then the compound should have NH4+. Now what are we doing? Understand, we had taken the observation, the test of the test 2 solution, the product which are formed of brown precipitates. That product we have taken, the brown precipitates, then we are warming. This brown precipitates also contains excess of NaOH because here we have added excess NaOH. So this compound on heating with NaOH or any alkali, when gives out a gas, ammonia gas, which turns red litmus paper blue, then the compound should contain NH4+ cation. That also we are going to compare and see the table which is given for the cation test. So just remember the brown precipitates and the formation of ammonia gas on heating with NaOH or warming with NaOH. The test 4 says, to the second portion of solution E, add 1 centimeter depth of dilute nitric acid and aqueous silver nitrate and no change is produced. No change is produced on adding acidified silver nitrate means chloride, bromide and iodide ions are not present. If they are present, we would have got white precipitate or cream precipitate or yellow precipitate of the halide ions, but we have not obtained. Okay, let's go ahead with test 5. It says that to the third portion of solution E, add 1 centimeter depth of dilute nitric acid followed by a few drops of aqueous barium nitrate and we have got white precipitate. Now again we are going to compare this test with the anion test, because the cation test is always done with aqueous NaOH. If we are using some other test observations, some other reagents for the test, then obviously these are the test for anions. Now if this is a test of anion and we'll compare it with the table. So let's go ahead with the question A. State what conclusion can be made about solid E from the observation in test 1. In the test 1 we have heated and obtained steam and water droplets on the top of the tube. So here we can say that the solid E is a hydrated compound, or we can also say it contains water molecules. That also we can write. It's one of the same thing. The question B says, identify the gas produced in test 3. Now we have already seen in test 3 that the gas produced in test 3 was ammonia gas. So let's write it here directly. It's an ammonia gas. If we go ahead with the next question, says next sub question C, state what conclusion can be made about solid E from the observations in test 4. Now again if we go with the test 4, we can see that there is no precipitates obtained with acidified silver nitrate, so halide ions are not present, or we can say halide ions or chloride, bromide or iodide ions are absent, or you can say are not present. It's one of the same thing. Identify the 3 ions in solid E. Now let's remember the observations we made, and now let's compare our table here. Yes, here the test which we had done was a sulfate test. Why I will tell you, because we had added dilute nitric acid and barium nitrate to our solid E solution, to the third portion of the solution, and we had obtained white precipitates. So this is the sulfate test, and we had got a positive test with the sulfate. So that shows that the sulfate is present. Obviously chloride, bromide, iodides are not present. Yeah, here ammonia, this is NH4 plus test, which we have already discussed that on heating with any alkali with NaOH, aqueous NaOH, aqueous sodium hydroxide, ammonia gas is produced. This we have already done in test 3, that the damp red litmus paper turns blue when the compound is heated with aqueous NaOH. Yes, so NH4 plus is present. And one more, the brown precipitates we had obtained, which remains insoluble in excess of sodium hydroxide. So one more cation is present, that is Fe3 plus. So you can conclude from the observations and the test that the 3 cations, the 3 ions present are, identify the 3 ions in solid E. So you can say ammonium ion present, or you can write the formula. Ferric ion, that is Fe3 plus is present, and sulfate ion SO4 2 minus is present. This is the test we had observed here. You can also see once again that the nitric acid and barium nitrate give white precipitate. this is sulfate test. Then ammonia gas produced on heating with aqueous NaOH, sodium hydroxide, that is the test of NH4 plus, and the brown precipitate which remains insoluble in excess NaOH, that is Fe3 plus test present. So here are the tests on solid E, and now the test on solid F. It's given us that solid F is zinc sulfite. This is not sulfate, this is sulfite, zinc sulfite. So what is the cation present? Zn2 plus, and sulfite is SO3 2 minus. So these are the two ions present in solid F. Now complete the expected observations. The student dissolves solid F in water to form solution F. The student divides solution F into 3 portions. Let's read. To the first portion of solution F, the student adds aqueous ammonia dropwise until it is in excess. Observations on adding dropwise and observations in excess. Now, as I said, NaOH, sodium hydroxide, is a test of a cation test. So let's go ahead and check that what is the test of zinc. Zinc is given here. On adding NaOH, we get white precipitate which is soluble in excess, giving a colorless solution. Now this is NaOH, but what about ammonia? White precipitates again soluble in excess, giving colorless solution. So this is also the observation with aqueous ammonia. Here we can see. So let's go ahead and write that in our question. Here aqueous ammonia, so adding dropwise, so white precipitates obtained, white precipitates obtained. On adding excess, it's soluble, giving colorless solution. White precipitate dissolves, giving colorless solution. This is the observation for zinc, that is Zn2 plus cation. To the second portion of solution F, the student adds a few drops of acidified aqueous potassium manganate. Observation. Now zinc is already done. Now we are going to go ahead with this test of sulfite ion, that is the anion. So again, let's check. Sulfite ion is here, and add excess small volume of acidified potassium manganate. Acidified potassium, aqueous potassium manganate changes color from purple to colorless. Now purple can also be written as pink, because on diluted in a solution, in place of purple it gives pink. So with aqueous potassium manganate, the potassium manganate decolorizes or changes to colorless. So that is the observation. So here again, acidified potassium manganate observation. So what do we have to write? The pink color changes to colorless, or you can also write pink color decolorizes. Anything you can write. Changes colorless. Okay, G question. To the third portion of solution F, the student adds 1 centimeter depth of nitric acid followed by few drops of aqueous barium nitrate. Now as we have already seen, that's the test of sulfate, and the sulfate test should not be given by sulfite. So we can just end up writing there is no change or no observation or no precipitates. Anything can be written. So this is how we are ending up with question 3 also. Let's go ahead with question 4. Question 4 says, now this is a planning and investigation question. Here I'll keep on giving you some tips how to write question 4 planning and investigation question. So let's go ahead and read the question. Solid cobalt oxide. Cobalt 2 oxide is a base which is insoluble in water. Now remember, it's a base insoluble in water. It reacts very slowly with cold dilute sulfuric acid to form a solution of cobalt 2 sulfate. Describe how to make pure dry crystals of hydrated cobalt 2 sulfate. You are provided with cobalt 2 oxide, dilute sulfuric acid and common laboratory apparatus. Now let's understand few points that here they have asked about to make pure dry crystals. So we should have the crystals dry also, and we should have the crystals pure. Now pure in the sense what? We should not have anything else other than the cobalt sulfate compound, other than few molecules of water, because it's hydrated. That shows that no other product should be present, neither the reactant should be present. Reactants also should be removed out fully from the cobalt sulfate mixture. Now that is possible only when we ensure that the sulfuric acid which we have used should be fully used up, and the cobalt oxide also should be either fully used up or should be removed out after the product is formed. So this is possible only when we use a limited sulfuric acid and excess of cobalt oxide base, which can be removed further from filtration because it's insoluble in water. So here are the few points which I've already said. Now one more point you need to consider here is that it's written clearly that it reacts very slowly with the cold dilute sulfuric acid. So if we want our reaction to be faster, we need to warm the solution. So keeping these points in mind, let's plan an investigation. That is, let's plan an experiment here. We are not investigating, we are making a product. So let's plan our experiment. So what are we doing? We are first mixing cobalt oxide and dilute sulfuric acid. So what we can say is that take dilute sulfuric acid in a beaker. Now I'll say that specify the names of the apparatus. So let's write the points. Name the apparatus used. This you should consider while writing an experiment. Name the apparatus used. So we are writing here, take the dilute sulfuric acid in a beaker. The second point is add excess of cobalt to oxide in the beaker. Now again I'm specifying that it should be added in the beaker which is carrying the sulfuric acid. Another important point which I'm specifying is excess. Why? Because the sulfuric acid taken should be fully used up so that it doesn't stay with the product formed. Now if solid cobalt oxide is insoluble, then if cobalt oxide is added excess, obviously we can see that the sum of the cobalt oxide, once the sulfuric acid is fully used up, it will remain in the solid form which can be removed from filtration. So the next point should be filter the mixture to remove excess of cobalt to oxide. So we have removed out cobalt oxide which we have added excess by filtration. So obviously now the products which we have obtained is cobalt sulfate and water. That are the only two products. Now we want water with it, but not in the liquid form, because we want hydrated cobalt sulfate crystals. So what are we going to do is that heat the mixture or heat the filtrate obtained after filtration. Heat the filtrate, and I'm specifying here till crystallization point. Now what is crystallization point? Crystallization point is keep on heating the mixture gently till few crystals start appearing at the side walls of the container. So here if we have taken a beaker, the beaker walls will start getting some small crystals on the side. Stop heating till that point. That point is called crystallization point. Once that point is obtained, allow the solution or allow the mixture to cool. Now if we cool the mixture, what is going to appear is that more of crystals will appear. More crystals will appear. The crystals will grow in size if we allow it to cool very gently, cool slowly. So more of the crystals will obtain. But yes, full water we are not going to evaporate. We are going to heat only till crystallization point. So obviously there is some water also present. So here again we will filter the mixture to remove out water. Filter the mixture to remove water. Obviously in the filter paper now we have got some crystals. We will wash the crystals with distilled water. Now specify here distilled water because the tap water contains salts which we don't want here. We are washing the crystals with distilled water because there should be no molecules stick or remain sticking of cobalt oxide or sulfuric acid on the crystals of cobalt sulfate. So we are washing the crystals gently with the distilled water. Once the crystals are obtained, dry the crystals gently between the filter papers. Now why am I drying the crystals in filter papers? Why can't we dry it by heating it? Because if we heat the crystals with direct heating, then the water of crystallizations will evaporate off and the crystals will break down into amorphous powder. So if we want hydrated crystals, we need to dry only gently putting the crystals between the filter paper so that the excess water is absorbed, and this is how we are going to dry the crystals. And this is how we have obtained the crystals in the dry form and the pure form. So this is how we are going to plan an investigation, plan an experiment. Whenever this last question is asked, this question carries 6 marks, so we should have at least 6 valid points out of this. But I never take a risk. I'll suggest that you should always write all the points with full description so that there are no chances of any cutting down of marks. Yes, I have one more video which gives you an examination tips of paper 6, which you will find at the end of this video. We'll also see a special video on how to plan an investigation, that is also given at the end of this video. So keep watching these videos and the whole paper to solve. I hope the question paper is solved very successfully and you find it very easy.